Hi friends, let us discuss a little more about the torsional vibrating system. Let us get into torsionally equivalent system. See, whatever topics we have been discussing within torsional vibrations are basically the steps or the stages that are required to attempt the numerical problems that you will be facing in the unit examination. Generally, theoretical part from this torsional vibration is never going to be asked, but definitely or mandatorily there will be one or two questions with respect to the torsional vibrating system. Now, in case of torsional vibrating system, you will have to study the system with a single rotor, a system with two rotors, and a system with three rotors. Now, for attempting the numerical examples for such system, the major content that you should be knowing is how to understand a torsional vibrating system that we have already discussed for a single degrees of freedom system and a multi degrees of freedom system. Next thing what you have to understand is how to manage the number of rotors and to govern a equivalent dynamic system. See, in our second module we have discussed about equivalent dynamical systems and all. Similar manner, we have to set up an equivalent system with respect to different sets of rotors which are being attached on a rotating shaft. Now, the topic here is related to that only. This is torsionally equivalent system. Consider a varying shaft with varying diameters at different sections. That means for the section L1, length L1, the diameter of the shaft is D1. For the section L2, the diameter is D2, and so on. Now, if I am applying a set of torque on each side of the shaft, a set of torsional couples or torsional forces will be induced in this system. Now, what we are going to devise is, we are going to devise a new set of equivalent shaft which is having a single diameter and a constant length. But that particular shaft should be having the same torsional effect as it had previously when the shaft was of varying diameters. So we are going to govern or devise a new shaft which is having an equivalent uniform diameter and a constant length, which will be having the same effect, same torsional effect that it was previously having when it was a shaft of varying diameter. Now, each section has different diameters. That means if I am applying torque on each end, the effect will be one. Let me apply a torque to that direction and to this direction. That means a small twisting effect will be there on this shaft. And at each point, the twisting or angular displacements will be different. For section 1 it will be theta 1, section 2 theta 2, and so on. Now let theta be the total angular displacement of the shaft. So the total angular displacement will be equal to what? Sum of individual angular displacement, which is theta 1 plus theta 2 and so on. Now we have the torsional equation which we have been studying from very long back. That is T by I is equal to G theta by L, where T is the torsion or torque applied, I is the moment of inertia, G is the modulus of rigidity of the material, theta is the angular displacement, and L is the length of the shaft. Now from this equation we can write down theta is equal to T into L divided by G into I. Now substituting this value in this one, we can obtain this equation as TL divided by GI, which is the general format. Now for this one, the torque and modulus of rigidity will remain constant because I am applying only a single value of torque, and G depends upon the type of material. Even though this is a shaft of varying diameter, the material is of uniformity, the type of material. So T and G will be constant for all the thetas, but the length of shaft and the moment of inertia will slightly vary. So this can be written as because the moment of inertia depends on the cross section of the part. That means it will depend on definitely the diameter. So this can be written as for theta 1, this will be equal to T L1 by G I1 plus for theta 2 it will be T L2 by G I2. For theta 3 it will be T L3 by G I3, and for theta 4 it will be T L4 by G I4. Now, from this equation, I can cancel out all these terms Tg, 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 and Tg. And the remaining portion I can write as L by I is equal to L1 by I1 plus L2 by I2 plus L3 by I3 plus L4 by I4. This is the general format that we have obtained. Now, I is known as the moment of inertia of the material and cross section of the shaft. Moment of inertia depends on the material. So, now for I, we have the equation for a shaft of circular cross section. We have pi by 32 multiplied by d raised to 4, where d is the diameter of the cross section. Hence, we can, for each cross section we have varying diameters here. So, when we substitute this in this generalized equation, the equation converts to L divided by pi by 32 d raised to 4. Here, d is the general diameter or the equivalent diameter, should be equal to L1 divided by what? L1 by I1 will be pi by 32 d1 raised to 4 plus L2 divided by, here I2 will be pi by 32 d2 raised to 4 plus L3 divided by pi by 32 into d3 raised to 4, and the last value L4 divided by pi by 32 into d4 raised to 4. Now pi by 32, this term will get cancelled from each component. Remaining will be L by d4 equal to L1 by d1 raised to 4, L2 by d2 raised to 4, L3 by d3 raised to 4, and L4 by d4 raised to 4. Now I am going to multiply total equation using d4 raised to 4. That means here if I multiply with d raised to 4, both d raised to 4 will get cancelled. So remaining will be only L. This is equal to what will be obtained here? L1 into, if I multiply by d4, I will obtain d4 by d1 whole raised to 4 plus L2 into d4 by d2 whole raised to 4 plus L3 into d4 by d3 whole raised to 4 plus L4 into d4 by d4 whole raised to 4. Sorry, we were multiplying the total equation using d raised to 4. So, we won't be having d4, we will be having only d. What I have done is, I have multiplied the whole equation using d raised to 4. That means, here both the d raised to 4 get cancelled, and for all these terms in this equation, the d will be obtained in the numerator. Now, what is this equation? This is the equation for L. L is the equivalent length of the shaft that we are considering. Now, let us assume a value for the equivalent diameter d. Now, this value for equivalent diameter d for all the cases will be assumed equal to the diameter of the smallest section. See, remember the figure that we have drawn initially. We had a section like this one, then we had this one, then we had this one, and we had this one. That means this section was having diameter d1, this was d2, d3 and d4. Now which is the lowest diameter here? It is d1, correct? So we are going to assume this value of the smallest diameter as the value of equivalent diameter d. So always keep this scenario in the mind. d1 is not the diameter of the extreme left section of the shaft. We are not considering it like that. We are considering it to be the diameter of the smallest section of the shaft. So if we consider or assume the value of d to be equal to d1, then our equation for the equivalent length of the shaft will be slightly changed as L is equal to, now here it will be d1 by d, which will be equal to 1 raised to 4 will be always 1, L1 plus, here it will be what? L2 into d1 by d2 raised to 4 plus L3 into d1 by d3 raised to 4 plus L4 into d1 by d4 raised to 4. Now, this is the equation for what? The equivalent length of the equivalent torsional shaft that we are devising. See, our topic was torsionally equivalent shaft. So, for such a shaft to be obtained or devised, we should have an equivalent length. That value of length will be obtained from this equation. Now, the d1 value was the value of equivalent diameter that we have substituted here. So, this topic and this equation is essential for doing the numericals that you will be facing with respect to torsional vibrations. That means you will be obtaining numericals from the case of single rotor, two rotor and three rotor systems. And for devising the solutions or reaching at the solutions, these equations that we have discussed in the torsionally equivalent shaft is a mandatory thing. So go through the video once again, understand how the derivations have been coming, and please keep in mind or write down this equation and let it be in your mind. Thank you.